Hello everybody, welcome back to episode 55 of the video series in which we program an entire video game from scratch, from beginning to end, in the C programming language. Before we begin, we are going to do what we usually do and talk about some of the comments that I received since the last video. First comment says, can I have some advice on cache friendliness? Should I try to align structures to cache lines? Also, I heard that using data types less than the native word width was bad for performance. Is that true? And if so, is it then not a good idea to try and pack data as densely as possible? Okay, so this ties into this is really a good segue into the mistake that you saw me make in the last episode where I accidentally used a data type that was too small. I used a 16-bit integer to hold the result of a calculation that ended up being larger than the maximum integer that a 16-bit value could hold, right? So just for reference, I'll show you what that was. Where was it? It was in DrawWindow, right? Because we started working on the DrawWindow function last time. And it was this line right here. Now, I originally thought that I could use a 16-bit integer for that calculation. Turns out that I can't, because the result of this formula here might end up being something like 90,000 or something. Like if you run the numbers, we have our game's resolution. We have 384 pixels across, 240 pixels down, which gives us a lot of pixels. Gives us like 90,000 something pixels, I think. 384 by 240, 92,000 pixels, right? So, if this in the bottom left corner was pixel 0, then this up in the top right corner would be pixel 92,160. Well, 92,000 is too big for a 16-bit integer. 16-bit integers can only go up to 32,000. 60 around 65,535 if it's unsigned. Still too small, which is why I made a 32-bit. Anyway, that was the source of my error in this function. We fixed that, but back to the original comment. Should I try to align structures to cache lines? So this is a really cool comment, and it's something that we could probably talk about for a long time. However, right now I'm going to say that we are not going to worry about it too much. I would say no. Typically, you should not ever really need to worry about aligning your structures to cache lines. Cache lines are typically 64 bytes. And I say typically because I cannot guarantee that every machine has a cache line of 64 bytes. Mine probably does, and yours probably does if you're watching this video on a PC. But who knows what other machines out there that could potentially run C programs compiled in C, written in C. But they might have differently sized cache lines. I will say that you might need to think about aligning your data structures to 4 bytes, 4096, 4 bytes, but we don't even really need to worry about that because we're not packing any data structures. Remember, I think we talked about this earlier. Let me go find one of these things. Yeah, see, like this data structure here. If we had not disabled this warning, I think we disabled a warning way up here. That's like, yeah, here we go. It's 4820. Disable warning about structure padding. We talked about this in an earlier episode, but basically this C compiler will, as it compiles your code and your data structures, it will add padding to the data structures as necessary to align them to, yeah, 4 bytes. Anyway, I won't go too far into that, but that's the only alignment that you really ever need to worry about, and we don't even really have to worry about it here because the compiler is adding the padding for us. The only time that you would want to specifically pack a data structure, which is what you would do with like pragma pack one something and then make your data structure, that basically tells the compiler to disable padding or not add padding to the data structure. And the only time you would want to do that is if you were, I think the only time you would ever want to do that is if you were working with a device or a machine that needed a very specific, needed the data structure to be packed in a very specific arrangement without any padding. A lot of times, if you're working with devices, if you're writing a device driver, that becomes a lot more important. But here in user mode, not typically a big deal. You want to let the compiler add that 4 byte padding for you as necessary so that everything aligns everything aligns nicely. Oh, well, and also if you're developing for a really small machine that has, a very, very limited amount of memory, then you might also want to think about packing your data structures more densely. Um, Again, it's not a concern here on this massive PC that has, several gigabytes of memory, not an issue. So if you have your structures padded correctly, let the compiler do it for you. Then you won't have to worry about, if you're aligned on 4 byte boundaries, then you will also be aligned on 64 byte boundaries. So everything is going to fit with your CPU cache lines nicely. Typically, not a big thing, not something that we need to worry about here in the context of this game. This also falls into the bucket of premature optimization, I would say. If we need to come back and do more really critical thinking about the alignment of our data structures, then we will, but we won't need to unless we need to really optimize this to run at like 1,000,000 frames per second for some reason. If we need to make this run on like a wristwatch or a pregnancy test or something, that's a joke. I remember reading in the news a couple months ago about someone literally got the original video game Doom to run on an actual digital pregnancy test, which I think is just another testament to the amazing resiliency and durability and portability of the original Doom source code. But everyone already knew that that game was a work of art anyway, and it could run on almost any hardware. Those are the sorts of things that if we ever need to come back and start worrying about structure padding, either for memory page size or cache line size, or any sort of like memory access size that needs to be aligned on 4 byte or 64 byte boundaries, either one. If we ever need to worry about those things, it's going to be because we're optimizing, and I don't want to get it too much into optimization just yet because it is premature. It's not time for that level of optimization yet. So the same commenter also asked a separate question. Also, I heard that using data types less than the native word width was bad for performance. Is that true? And if so, is it not then a good idea to try and pack data as densely as possible? So this is another great question. Different question than the alignment, the memory access alignment question. This is a different question. Although related, it's different. And it's also a really interesting question. And the answer is not simple. The answer is it depends. It depends on um, the usage pattern of your machine. It depends on the machine that you're running on. CPUs, modern CPUs are incredibly sophisticated, complicated things, and your CPU is doing things that you don't know about. Even if you are coding in C, or even if you're coding in x86 assembly, your CPU is still doing things that you don't understand. For example, your CPU will be rearranging instructions on the fly that you don't know about. Your CPU will be profiling the usage patterns of your threads and actually doing optimizations that you never asked for. Just based on these profiling and analyzing mechanics that your CPU is doing. Um, so um, that being said, it definitely can be, and that is what made me think about this right here. So, I've been using these data types from the stdint.h header, and that's just because I really like them. I really like knowing the exactly how wide my data types are going to be, and that's just something that appeals to me aesthetically. However, I will say, you know there's nothing wrong with you just making everything, an int, for example. Like, you know I I tend to like to, quote unquote, economize my data type sizes on the fly, and I'll set and I'll try to make them 16 bits if I know that the calculation doesn't require anything bigger than that, and I'll try to make them, a 32 bit if I think it's bigger, and I'll make them 64 bit if I think it's a really big number. And that isn't necessarily the best practice. A lot of, like, this is a perfect example. In that last episode, I think I set myself up for failure in that last episode because, you know, I never would have had to worry about this decision. This is a decision that I never would have had to have made if I just made everything an int, and you will probably make fewer mistakes if you just make everything an int like that. But I feel like, I don't know, I just like these data types so much that I want to keep using them. So does it matter? It definitely can. It definitely can have an impact on the performance of your program. So you either can optimize for memory usage, or you can optimize for speed. If you're making something like a large array, or a large data structure, or an array of data structures that may contain, thousands, tens of thousands, hundreds of thousands, or millions of members, in that case, it may be really important to optimize for memory footprint. It can make the difference it can make megabytes, even tens or hundreds of megabytes of difference in your program, uh, if you use smaller data types. In other words, use 8-bit integers when you can, instead of using 32-bit integers, etc. However, it is often faster in terms of processing speed, to use larger data types, and that's where these, let's see, like, int fast 16t. That's where these data types come from, which these are also part of the stdint.h header file. And essentially what these are, it's they I should say, they promise to be a way of being a portable way of letting the compiler know, hey, um, basically, I want this to be the fastest possible data type that you can make it that's at least 16 bits wide or something like this. Let me see. Let me go ahead and look it up so I can int fast 16t. So it's guaranteed to be the fastest int with a size of at least 16 bits. I think that's exactly what I just said, right? As opposed to, int, you have no idea what size int is going to be on different machines, right? Like on my machine, it's always going to be 32 bits, but you can't guarantee that for other machines. And from the official documentation, designates the fastest signed integer type with a width of at least n. That's at least that size. So okay, so this could end up being 32 bits. This data type right here could end up being 32 bits if the compiler deems that it will be faster in terms of processing speed to make that data type 32 bits, right? And what's the counterpart to that? Oh yeah, least. Let's look this one up too. Least 8. Let's look up the documentation for this one. Int least 8 underscore t is a type def of char, not of short or int, because the standard requires the smallest type with at least 8 bits. So that's why I was saying earlier that you can either optimize for memory usage or for processing speed, one or the other. Those are the two opposite ends of the spectrum, and that's the balance that you're trying to achieve when you're trying to optimize things. So that's where these data types come in, which I haven't used them in my program, and I may or may not. Like this goes back to the the mantra about premature optimization. I may come back and start converting things to these data types if it turns out that they will be faster. Using a larger data type often can be faster, but sometimes it's not. Sometimes it makes no difference at all, and that's why I mentioned about CPUs being so complex that I think the only way to really know is to benchmark and to profile. So that's why I'm not going to go and just blindly convert everything into this fast data type, quote unquote fast, because I actually have no idea that it's going to make anything faster at all for me to do that. And I have a feeling it probably won't. I have a feeling it probably won't make any difference. Um, but it might, and it all depends on how you're using it, how your program uses these data types, your access patterns, and all this kind of stuff. Which is why I say the only real way to know if it's going to make it faster or not is to try it and benchmark it, profile it, see if it's faster, see for yourself. That's really the only way to know. And you know when I'm ready to really start optimizing this program, this video game, then that's when I might start investigating the use of these data types um, for any amount of speed up that I can possibly get. But I'm not going to do it right now because I think it would be premature optimization. So there you go. I hope that answers your question. It's it's kind of a holy grail of a topic because it's something that we could continue talking about for a long time. Okay, so next commenter says yet, and maybe he meant to say yeet. I don't know. That's what the kids are saying these days. Okay, next commenter says, what I've done whenever I've made a color union is just to have a union color struct char r g b a and then hex, so that way I can just use color.r or color.g. For me, I find that better, um, which is perfectly valid. It's a great idea. If you remember from last episode, um, in the last episode, we introduced the idea of a union, which is what we have made. We turned our Pixel 32, we converted it from a struct into a union, which, if you remember, a union is just, um, it's basically a way to tell the compiler that you can refer to this space in memory by in two different ways. I can either refer to it as the struct, or I can refer to it as, the whole thing, which is a D word, which is really the same thing, right? It's like we knew all along that our Pixel 32 was just, red GBA, the whole thing, and which is the exact same thing as a D word. And we knew the whole time that those were the same thing, but we needed a way to tell the compiler that those are the same. So that's why we made that a union. Um, and the way that this commenter proposes it works perfectly fine. So yeah, use whatever makes the most sense to you. Okay, next commenter says, another question about portability to Linux, which I've talked about a dozen times. Maybe later, not today. Okay, next comment says, after following this video, I'm getting this error, link 1104, cannot open file, and then the path to the executable. So whenever I get this error typically means some other process on the system already has a handle open to this executable, and that's why the compiler cannot overwrite the executable, and that's causing your build to fail. This can happen for a lot of different reasons. Number one, it can be a bug in Visual Studio, and I've found that I have to often what I try to do first is either just start the build again, just try to build again, and that'll usually fix it. It's because Visual Studio, or some, process of Visual Studio, some process that is a child of Visual Studio, still has a handle open to, gameb.exe or whatever it may be, which is causing your build to fail. Just try to build it again, and next time it'll work. And if that doesn't work, then I close Visual Studio, restart Visual Studio, then I restart the build, and that will typically work. If you're still having problems, it can be other things. It can be antivirus, which could be holding a handle open to the file. Like your antivirus antivirus program is like still scanning the executable, causing it to hold that handle open to the process. And lastly, it can also be check that you don't have multiple instances of the executable already running. And remember, we fixed that in our game with this game is already running function. Creates this global mutex. It ensures that only one instance of the executable can run at one time. But if your program doesn't do something like this to ensure that only one instance of it is running at a time, then double check and make sure that you don't already have multiple copies of it running in the background. Can cause your build to fail. It will cause your build to fail. Okay. So let's see. Next commenter says, I have had technical difficulties getting Visual Studio up, so I'm following along in code blocks. I have to admit I'm getting different results than you, namely in that it still won't show. And this is a comment on episode 1, by the way, so this is way back when I had an int main. It was the only function I had, right? It still won't show the actual number of arguments. It just prints arguments. However, this is an insightful and approachable tutorial. Okay. Unfortunately, I don't know anything about code blocks, and you didn't provide me with enough context um, to see why your code might not be working the way that you think it is. Um, all I can say is if you couldn't get Visual Studio working, it is probably because you're not using Windows, or maybe because you're using like Windows 10 in S mode or something, or something along those lines. And if that's the case, if you're running something else other than just Windows, regular, traditional Windows, you're probably going to have other issues as well. If you can't even get Visual Studio installed, then you're probably going to have other major issues trying to get this game to run on your machine too. So, um, yeah, I don't know what else to tell you. Um, you should probably use Visual Studio. Okay. Next comment says, does this game use the GPU in any way? From my understanding, the GPU can only be accessed using an external library like API like OpenGL or DirectX. If this is true, then will you ever include this subject in your videos? Good question. Currently, the answer is no, we are not using the GPU in any way, at least in any meaningful way. GDI, we are interfacing with GDI, which is a very, very old school Windows graphics interface. If you recall, we're using it to blit our memory buffer onto the screen. And way under the hood, there are some parts of GDI which do take advantage of the GPU, but that's nothing that we have any control over. Um, that is basically something that's done by the Windows operating system under the hood that we don't have any control over. Um, in a general sense, you are correct that if you want to use the GPU, you need to use an API such as OpenGL or DirectX. Um, yeah, but no, we're currently not doing that. Will we ever in the future? Um, I don't know. That's a good question. I don't think we'll ever need to, because remember this. You remember how simple this game is graphically. It's not ever going to be 3D, and it's a very small resolution. So I think almost any machine out there is going to be able to run it just fine without any sort of help from the GPU. So probably not. And also, if we did, I fear that would take us, that might take us even farther away from our goal of portability to different machines. Because if you think of other machines such as a Raspberry Pi, for example, may not have access to, um, well, it definitely won't have access to DirectX. May not have direct access to OpenGL. Um, so I don't know. I mean, I may go there in the future, in the distant future, but I don't have any plans to do that right now. Okay, next comment says, just started learning C. I want to make a game in C and assembly, but where should I start? Please let me know. Thanks. You can start right here, my friend. He also says, dude, how'd you learn C? I'm not that new to programming. I only know a bit of Java. I'm interested in low-level topics. So I want to learn C, then assembly. How do I learn C for beginners? Um, yeah, I mean, I don't have a whole lot of tutorial material on hand for you. Like I never took a class on C, and I think I talked about this in one of my earliest videos, like episode 1 or 2, is that I actually wish that my school had taught C. But back when I was going to school in the late 90s, C++ and Java and object-oriented programming in general, that was the only kind of programming that anyone taught back then. I had to come across, I had to develop my own love of C on my own. I started realizing slowly over time, over years, that most of the stuff in C++ is a distraction in general. And that's when I started going back to the basics, and I started teaching myself, how to really get good at C. And I don't think I'm really good at C. I'm just I still think I'm an amateur at C, really, but um, that's not stopping me from trying to develop this video game. And so that wraps up our comments. Let's see how long that took. I feel like that took about 30 minutes. It did, 31 minutes. Let's do something. Let's move forward in this game. Here's what I want to do. I want to keep going. We obviously need to keep going with this draw window function that we started in the last episode. And I added. You can see I added a couple of asserts off camera right after the episode ended last night. Not last night, but last time I recorded, I added these just to say, your window width does need to be a multiple of 4, and it obviously your window needs to fit on the screen because I don't want to have to deal with trying to draw outside the bounds of the screen, because remember that causes crashes. But this bordered thing, we have 2 questions to ask ourselves, and that is, how do we want to draw the border? Like, I suppose I should open like some sort of paint situation here. And do we want to draw the border of the windows manually, or do we want to do it? Do we want to create bitmaps and load the bitmaps from our archive that comprise our border? So let's say that's our window right here. And what if we want to draw a border on this window? What is the border going to look like? Is it going to look like, maybe we just draw like a concentric square or concentric rectangle like that, and maybe that's all we need for a bordered window. Or maybe we want to do something nicer and like give it sort of a rounded effect like this. Something along, even something like that, would add a nice touch, I think. Give it rounded corners like this. Yeah, like that. And then we have to ask ourselves, what do you want the border to be colored? Do you want it to just be white, or do you want to color it blue or something? That, I don't know. I do know, however, though, that I do want to emulate. The game that we're trying to emulate is like a Dragon Warrior or Final Fantasy or Pokemon style game. And I remember one of the things in the old Dragon Warrior game is that when you are in combat, or when your HP, when your health drops below a certain point, then it starts painting everything with like a red color to let you know that you're almost dead. Um, we'll definitely be incorporating something along those lines. Um, so yeah, that is the question, and I'm still actually trying to make the decision as I'm talking right now of whether I want to. What I could do is I could take every like 4 pixel wide piece of this, and I could save it as I could save it as a bitmap, and then I could load it in, and I could draw it with blit 32 bit per pixel bitmap to buffer, like so, and then I could just do a loop and just keep drawing 4 pixel slices of this until I've gone all the way around the window. Or I could just draw it manually with like memset statements, memset, memcopy, stos-d, all this kind of stuff. I don't know. I'm sort of leaning towards that option. Secondly, there's another thing that I thought of that I really want to do, and that's, I think, I want to replace this parameter with something else, something like this. If I go back to main.h and I go back to my function declarations, draw window. What if I replace this with dword flags? And then I go back to main.c and I replace this with dword flags. And the reason I'm thinking like this is because this pattern, this is something that is very ubiquitous in Win32. It's something that you see a lot, both in the Windows API and also internally, in Windows itself. Is you have like a function or an API that it'll take some basic parameters, and then it'll take just like a bit field of all these other options. So that's kind of what I want to do here, because what this does, the reason why I want to do it this way is because it allows us to add new features to this draw window function, to add the bordered option. What if I want to add like a shadow effect to it? What if I want to add like I don't know, what do you call it, like a jiggle effect, or a like if you're in, imagine if you're in a battle and the enemy hits you, you may want the window to like shake, to vibrate, right? Which may also coincide with like your Xbox controller vibrating at the same time, something along those lines, because it adds extra effect and immersion to the game. Yeah, so it basically allows me to continue adding new features to this draw window function without having to modify the function prototype, their signature, without having to add extra parameters. I don't have to keep adding extra parameters to the draw window function. I can just keep adding new flags to this bit field. So pretty sure that's what I want to do. And so I need to add some, let's see, it's a struct. Where's my enum? There's my union, struct. There it is. So enum. So let's make a new one. Type def enum, and we'll call it window options or window flags. We'll just call it window flags for now. There we go. And okay, we're going to do window flag bordered equals 0, right? Window flag. What's another one? Oh, this one's kind of cool. I thought of this. Horizontally centered equals 1, right? And basically the idea behind this flag is if you specify this flag, then it will essentially ignore the x coordinate that you supplied. It will ignore the x coordinate that you supplied and simply calculate, based on the width of this window, where does it need to be in order for it to be horizontally centered on the screen. And that will prevent us from having to calculate it every time we want to just place a window horizontally centered on the screen. And of course we can also do vertically centered equals 2. And what's another one? Window flag shadow effect equals 4. Oh, sorry. I think, sorry, I should have started on 1 here. 1, 2, 4, 8, and so on and so forth. The reason why these flags can't just go, 1, 2, 3, 4. They have to go 1, 2, 4, 8. And if I keep going, the next one would be 16. The next one will be 32. They have to go in powers of 2. And the reason they have to go in powers of 2 is so that they can be mixed together bitwise and not overlap, right? So this can be written lots of ways. So like the number 1 is the same as 1 with shifted to the right, or sorry, shifted to the left 0 bits. The number 2 is the same thing as 1 shifted to the left 1 bit, right? Because think about it, if we have, now imagine we're writing in binary 0y, 1, 2, 3, 4, 5, 6, 7, 8, and we put a 1 right here in the least significant bit. That's the number 1, right? And if we shift this bit to the left 1, then we get this, and that's the number 2, right? So same concept here, which is the same as, sorry, 1, 2, 3, 4, 5, 6, 7, 8. So start with the number 1. If we shift it 2 places to the left, then what do we get? We get the number 4, right? Because this is the 1's place, this is 2, and this is 4. And again, you can write this, you can write these as, decimal, hexadecimal, binary, whatever you want. I think you can even just directly write it like this. No, you can't? I thought it would let me do binary like that, but I guess not. Anyway, let's just put 8 back there. Anyway, that all makes sense, right? I think I explained that pretty well. Let's do another one just for window flag shake equals 16. Alright, so on and so forth. And I'll comment this for use in the DrawWindow function. Right. Now I go back to DrawWindow, and now instead of having a parameter that's, I don't have to have a separate input parameter for each one of those options. I can specify them all, and any combination of them in this flags bit field. So I can do see how it used to say, if the bordered Boolean variable was true, then I do all this stuff. Now I can do if flags bitwise and window option window flag bordered. There we go. So that's how that changes. Now we need to actually create a border around this window. So let me go ahead and run this real quick just to see. And my PC has obviously run Windows updates since the last time I built this game, And every time you run Windows updates, you have to download new symbols for every module, every Windows module. All right. Here's this. Okay, so what I have down here is a small blue rectangle at these coordinates. It looks like X, probably X32 and Y200 or something. And I drew that in overworld. Oh, look, I was right. X32, Y200, it's 128 pixels wide and 32 pixels high is my window color, and I'm sorry, window height. And here's my color right here. That is obviously still wrong. This is B, because remember the color of the window is blue. So ARGB, ARGB. So that must be right. But let me test. If I turn this off and, oh, sorry, BGRA, BGRA. BGRA. So let me turn blue off and green on and double check and make sure that now this should create a green window. Yeah, now the window is green. Let's turn green off and turn red on. Now it's red. Okay, good. Just making sure we had all of our bytes in the correct order. BGRA. Okay, so now our flags, this false needs to go somewhere else, and we're going to do window flags bordered. Just like that. And if we wanted to, we could actually use bitwise or to combine this with another flag, like window flag horizontally centered, right? So if you bitwise or these two things together, you will have a combination of these two things, right? So that's how I'm saying we can use these flags to mix and match however we want. And I'll go ahead and leave it like that. So we should produce a window that is both bordered and horizontally centered. So let's do horizontally centered first. Window flags horizontally centered. Because that's essentially going to change our X coordinate, right? Which I'm going to put right there. So we need to calculate the center. How are we going to center this thing? X equals game res width divided by 2, because that's the center of the screen right there, right? Minus width divided by 2. That's the I have a feeling that's going to work. I think that's how you horizontally center the window, right? So let's double check that. So now the window should be horizontally centered in the center of our screen. And it looks like it is. Awesome. Oh, by the way, I disabled the random monster encounters. I disabled that by going to, let's see, initialize hero, I think it is. So this gplayer.random encounter percentage, I will probably end up changing this because it's like the opposite of what I want it to be. Like if I change this to 90, then you have a 10% chance on every time you take a step, you have a 10% chance of encountering a monster. If I make the value 80, then you have a 20% chance of encountering a monster every time you take a step. And if I make this 100, then you have a 0% chance of encountering a monster every time you take a step. So effectively, if you want to disable random monster encounters, then you set random encounter percentage to 100, which again, I know is counterintuitive, so I should probably change it. But let me go to overworld. And it's like random monster encounter. Hold on. Portal. No, it's not portal handler. It's when here it is. This is every time we finish taking a step, we generate a random number, and then we do some modulo arithmetic to determine whether we should do a random monster encounter or not. So, and obviously if it's 100, then your random can never be greater than that, and so you'll never encounter a monster. But anyway, that's not really what we're working on today. We can see that our horizontally centered flag does work correctly, which is cool, right? So now how much time do we have? We don't really have very much time left, so we only have like 6 minutes left. Let me go back to main.c. Let me go back to DrawWindow, not DrawDebugWindow, just DrawWindow. Okay, I think this is all fine. We should probably do the same for window flag vertically centered. We should probably do the same thing with the Y coordinate there to get it vertically centered. And yeah, let's see. All right, flag bordered. How do we want to do this? Okay, so I'm going to just kind of guess here. The border color is just going to be white for now. I don't want to do that. I want to do I just want to do the top and the bottom. That's going to be 0. times height. Okay, so I think what this is going to do is this is going to put a white stripe at the bottom and the top of the window, and then I'll have to do the sides. But let me see. Or maybe it'll just crash, I don't know. Okay, good. We do have a white stripe at the bottom and the top, so at least I'm doing what I think I'm doing. Nice, nice, nice. Let's go ahead and, while we're doing this, while we've done our proof of concept, so let's take the red. I don't want to make it red, I want to make it black. Draw overworld. Just go ahead and make this window black. Okay, now how to do the sides. And we also have to make the decision, is the border going to cut into the inside of the window, or is it going to pad around the outside of the window? And it's definitely safer that the border eats into the inside of the window, because again, we don't want to get into a situation where we accidentally draw off the edge of the screen. So all right, let's one step at a time. Let's do the sides. All right, I think we need to do equals 0. Row is less than height. Row plus plus. We're going to essentially we're going to draw 2 pixels, right? We're going to draw one white pixel on the left side of the window and 1 pixel on the right side of the window. And we're going to do that repetitively for each row until, yeah. And we've already done row 0, right? So we can start on row 1. And we've already done the top row, so we can stop when we have reached height -1. And just for consistency's sake, let's stick with Stos D that we've been using, and instead we'll just do size of pixel 32, which is 4 bytes. Oh, sorry, this is actually, that's a count, not a, it's a count of D words, not a count of bytes. So let's do 1. Yeah. Okay, so I think this should be sufficient for the left hand side of my window. Let's double check it and see. Perfect. Oh, not perfect. I see a little black blip there at the bottom where we apparently should not have started at 1. Should we have started at 0? You can see at least now my build time is much faster now that I have disabled code analysis on every build, and also, let's see, and also create an antivirus exclusion for this directory. Okay. Now I wonder if this is actually correct. Because if this works, it makes me think that maybe my window is 1 pixel. It makes me worry that maybe my window is 1 pixel less than what it actually should be. Like if I supplied 64 for the height here, is my window actually 64 pixels high, or is it 63 pixels high or 65 pixels high? I don't know. Yeah, we don't need that. We'll worry about that next time since we're already over time. So we basically just want to do, we want to recalculate memory offset. We want to push it. We want to push it to the right hand side of the screen, right? Or sorry, right hand side of the window. Right? Let's see if this gets us a window with a border on all 4 sides. And it does, but you can see that it is tapered on the ends, which actually is probably better. Like that's more what I want it to look like, I think. Oh wait, no, it's actually outside the bounds of our window. So I think what I need to do is, I think I need to bring it in 1 pixel. Like that. There we go. So there you have it. I think that does it for today. We have drawn a horizontally centered window on our screen with a border around it, which is pretty cool. I think next time we'll probably finish off our bordering stuff by adding, like, I want to do like, you know, this type of stuff right here next time, where our edges are slightly rounded off, and you know, maybe we might have like a double thickness border. Might look cool. Or maybe we just put like a gray line around it to give it sort of a tapered or 3D, you know, kind of like faux 3D look to it. Yeah, so you know, the sky's the limit. But since we're already over, that is all the time we have for today. As always, I want to thank you for watching, and if you enjoyed what you saw on the video today, if you want to, you know, watch me continue developing this video game until completion, then please subscribe to the channel. Please hit the like button and tell your friends, all that good stuff. Don't forget that we have a companion GitHub repository. Go to my GitHub repo. There's a companion. All the source code is there basically, so you can clone the repo and follow along at home. Lastly, if you have any questions or comments about this video or any previous video or anything at all, really, just leave your comments on the video. I, as usual, will respond to any interesting questions or comments in a future episode. So, with all that said, that's all for today. Thank you very much again for watching, and I'll catch you next time. All right, bye.